Hello viewers, in today's session we are going to discuss another important and conceptual problem from derivatives. And here in this session we are going to discuss this problem in which we are given a function f of x that is a combination of two mod functions. So here we have 3 times mod of 1 minus x minus 5 mod of x minus 3, and we have to show that this function f of x is strictly increasing function in this open interval, that is 2 comma 3, right? So here let us first see the definition of strictly increasing function, right? So we have already solved these type of problems in our earlier videos, and we have already discussed the concept of increasing and decreasing function in detail. But here let us quickly see the definition of strictly increasing function. Now see, if we have a function, say y is equal to f of x, right? And if the derivative of this function f of x it exists, then the function y is equal to f of x, which is defined in some domain, then this function is said to be a strictly increasing function if the derivative of this function is positive for all values of x belonging to the set of the domain, right? And here we write d for domain. So the derivative must be positive or it is greater than 0 for all values of x belonging to the domain. So we'll use this concept in solving this problem. So here we have the function f of x, that is 3 times 1 minus mod of 1 minus x minus 5 mod of x minus 3. So let us quickly redefine this function f of x, or we'll try to write this function f of x as a linear function of the form ax plus b by using the definition of mod function. So mod of p is defined as positive p whenever p is greater than 0. Mod of p is 0 when p is equal to 0, and mod of p is negative p when p is less than 0, right? So here we are given this interval because we have to prove that this function f of x is a strictly increasing function in this interval, that is when x belongs to 2 comma 3, or we can write x greater than 2 but less than 3. So now let us first express these mod functions using this definition of mod function. So we have mod of 1 minus x is equal to a positive 1 minus x whenever 1 minus x is greater than 0, or x is less than 1. And this is 0 when 1 minus x is equal to 0, that is x is equal to 1. And mod of 1 minus x is negative 1 minus x when 1 minus x is less than 0, that is x is greater than 1, right? So here we have x is equal to 2, and here we have x is equal to 3, right? And mod of x minus 3 can be written as positive x minus 3 whenever x minus 3 is greater than 0, that is x is greater than 3. And this is 0 when x minus 3 is equal to 0, that is x is equal to 3. And here we have minus x minus 3 when x minus 3 is less than 0, that is x is less than 3. So this is how we can define mod of 1 minus x and mod of x minus 3. So now here we have the interval x greater than 2 less than 3. So we have to define mod of 1 minus x and mod of x minus 3 in this interval only. So now see, here we have mod of 1 minus x, and mod of 1 minus x is equal to negative 1 minus x when x is greater than 1, right? So we'll define mod of 1 minus x is equal to negative 1 minus x when x is greater than 2 and less than 3. And mod of x minus 3 is defined as the negative x minus 3 when x is less than 3, right? So here we have x less than 3, so we can now write mod of x minus 3 as negative x minus 3 when x lies between 2 and 3. So now let us substitute these values in this function f of x. So we can write f of x as 3 times minus 1 minus x, and then here we have minus 5, and here we can write minus x minus 3 because mod of 1 minus x is negative 1 minus x, and mod of x minus 3 is negative x minus 3. So let us simplify. So we have 3 times minus 1 plus x, and here we have minus 5 minus x plus 3. So we can now write minus 3 plus 3x, and here we have plus 5x, and here we have minus 15. So we can now write 5x plus 3x is 8x, and minus 3 and minus 15 is minus 18, right? So our function f of x is now equal to 8x minus 18, which is of this form, that is ax plus b. So this is a linear function. So let us differentiate f of x. So the derivative f prime of x is equal to d by dx of 8x minus 18. So here we can see that the derivative of x is 1, the derivative of 18 is 0, so we have simply 8. So the derivative of f of x, that is f prime of x, is equal to 8, and this is a positive quantity, right? So f prime of x is always greater than 0 for all values of x belonging to the domain. So here f prime of x is always going to be positive in this interval, that is x belonging to 2 comma 3, right? So this shows that the definition of strictly increasing function, that is f prime of x is greater than 0, is satisfied by this function in this interval, that is x belonging to 2 comma 3. So f prime of x is always going to be greater than 0 because 8 is a constant, and it is greater than 0 for all values of x belonging to this interval. Hence this function is a strictly increasing function in the given interval.